Welcome all once again to Coding Talks and this second episode on S3, which is one of the object storage service from Amazon Web Services or AWS. Yesterday on 4th February 2022, we had a session on understanding about the basics of S3, how we can create a new account in the AWS and get quick start with creating an S3 account. We also understood how we can create a bucket, the different prefixes by which we can mimic the folder structure or directories in a file system in S3. And we also understood how we can set the different permissions by which a user can authenticate. We also understood the different ways by which a person can interact, or person or even an application can interact with S3. One popular way is through the SDK. That is the way by which applications are all interacting with the S3. Another common approach to interact with the S3 account is through the console or the AWS console, which is the dashboard which you get after logging into the AWS. You can also interact with the S3 using the AWS CLI, which is a command line interface which is available either as an installation on your local system or as a web interface from the AWS console as well. So different approaches you can rely upon. We also understood that we must be careful in setting the region that is closest to the area where your users are actually using the application. So the region that you must select must be very closer to where actually your users are going to use the application. So that way we can minimize the latency. And there are different features of S3, and if you are not interested in using such features like the versioning, then the utility, the inventory based object tagging, the different metrics and the storage class analysis or the transfer acceleration services like the CloudFront, feel free to turn it off so that you can reduce the pricing. So you will be charged for basically storage request and the data transfer pricing and the different other features that are applicable to the S3. We have covered quite a lot of that in the previous session. If you are newly listening this session, I recommend you to listen that previous session as well, which is an overview of S3, which is available from my podcast channel. That is, you can listen from any one of your favorite podcasting platform as you like. So we can start the session. Today we are focusing on understanding a bit about more advanced topics on the S3. It's not very advanced, but still it's an intermediary to advanced level concepts by which you can get a familiarity of better working with the S3 service. So myself Vishnu, I am a .NET programmer from Thiruvananthapuram, Kerala state, which is on the southern part of India. I have more than 15 years experience in IT, working with the different cloud vendors, and I occasionally podcast as well as I have a YouTube channel which is available on the YouTube, which is the Coding Talks with Vishnu. So you feel free to check out the episodes either in my YouTube channel. I also have a meetup group and I am an AWS community builder for the year 2021-22. Feel free to check out the different past episodes as well, either in the podcast or from the YouTube channel. So with that, I hope you already have a good understanding about an overview of S3. If not, I recommend you to listen the previous session, which is available in my podcast. With that, we can start the session. So we understood a bit about an overview, the way by which we can store the objects. We also understood that we can store the metadata along with an object in S3. So the object can be of different files. It can be a JPEG file or document or whatever your application is actually using. Now we are going to understand how we can better optimize the storage in S3. As I discussed earlier in the episode yesterday, we understood that when we create a new bucket and store something inside S3, by default S3 stores that in a class called the standard. So the different classes are the base by which the S3 provides different additional features to the object which we are storing. So the basic default storage class is called the standard, by which you can access an object at any time. It's intended for frequently accessing objects. So that's the reason why it's available as a by default, and that class is called the standard, and it's specially suited for frequently accessing objects. So if you are creating a new bucket and storing something, by default it will be in the standard class, unless you have changed the default storage class to something else. So standard must be the default, but you can change the storage class. Why we are going to change the storage class depends upon how much we want to optimize the cost and the storage associated with S3. If you have frequently accessible data, you must either select standard, or there is another nearly another one class called the reduced redundancy class as well, which is suitable for non-critical reproducible data. So standard and reduced redundancy are the most common class used for frequently accessing objects. You must select the standard rather than reduced redundancy, because reduced redundancy is almost the same price, or nearly more or less same price as standard, and that's only suitable for non-critical reproducible data. So standard must be the one which is usually suited for frequently accessible objects. But if you feel that you are storing something inside the S3 and you don't want to frequently access that object, then there is another two classes which are available for infrequently accessible objects, which is called the standard infrequent access and on-zone infrequent access. So there is a difference between these different kinds of classes, like the standard and versus the standard infrequent access. So if you feel that your objects are not to be accessed frequently, you can select that to standard infrequent access, as well as there is another similar class called the on-zone infrequent access as well. If you are feeling you don't want to use if you don't want to access the data frequently. On-zone means that the copy of that data or the object will be stored only in one particular availability zone. AWS has the concept of different zones available across their geographical area. So the entire geographical area is split into different zones. Each zone has its own power, independent cooling and everything. When you mark your object under the on-zone infrequent access, that means that their data will be stored only in a particular zone, and the cost, when you select either the standard infrequent access or the on-zone infrequent access, it will be the storage cost will be much less than that of the standard or the reduced redundancy frequently accessed objects class. So that's the one advantage you will get from selecting these kinds of infrequent accessible objects. The storage cost associated with S3 for storing that particular object will be much lower than that of the standard. And similarly, if you want to archive some objects that you don't want to access, or you feel that you will only rarely access those objects, then you can move that to a different class which S3 provides you for archiving the data, which is called the Glacier and a Deep Archive. So three kinds of three categories of classes which we discussed. One is the frequently accessible objects. So if you feel that you want your data to access frequently, you should select the frequently accessible class category, which consists of two main type of classes, which is one is the default standard class and the reduced redundancy class. Reduced redundancy is specifically suitable for non-critical reproducible data. Then if you feel that your object should be in an infrequent kind of category, you want to reduce the storage cost further, you can select the infrequent access objects category as well, which consists of two classes, that is the standard infrequent access and the on-zone infrequent access. Then if you feel further that you will be rarely accessing only your objects and you still want you to store your data inside S3, you can select the archive classes which are provided by S3, which is the Glacier and Deep Archive. So these classes are comparatively much cheaper in terms of storage cost. But the one thing you must understand here is, if you store something inside this Glacier or Deep Archive, and if you want to retrieve it frequently, other than the minimum stored time recommended by the S3, then you have to provide you will be charged for the retrieval. You will be charged for the retrieval of objects from these particular classes like the Glacier and the Deep Archive. If you check out the documentation of S3, Amazon shows a comparison of these different classes, like the standard, reduced redundancy, standard infrequent, on-zone infrequent, as well as the archive classes like a Glacier and Deep Archive, and how each one differs in terms of storage and how the retrieval cost will be. And based on those different features or associated features related to these separate classes, you can take a decision like, okay, I can store my data, or the objects associated with a particular bucket can be of this particular class, and that way you can optimize the storage as well as you can reduce the cost. Reducing the cost is one of the main reason by which organizations are moving to cloud. They want a scalable, organizations need a scalable application, highly performance application. At the same time, they want to reduce the cost associated with the infrastructure and all. So as a programmer or developer, or whoever who is involved in the project, you should be responsible for selecting the best optimized storage and cost based classes for storing the objects. So that's the reason by which, instead of providing a single standard class, S3 is providing these different classes based on whatever the application needs or whatever the organizations need. So, but sometimes the problem is like, initially when we start, we feel okay, we can store the data, store the object under the standard class, but we will not be sure like where we want to store. Is it going to be a infrequent one, or is it going to be a rarely archivable type of data? Should I select standard or deep archive? So such confusions can naturally happen. To avoid such thing, to reduce such decision issues, S3 provides a class called intelligent tiering. So if you select that class, S3 will automatically analyze your objects, how frequently you are accessing, how frequently your application is accessing those objects, and based on that, it will move the objects within standard to infrequent access or archive accordingly. So if some data is if you store some data standard, and if you select the intelligent tiering class, automatically the S3 will analyze that particular objects and the pattern by which how frequently that particular data is accessing by your applications, and then move accordingly to a different class suitable for that particular object. So intelligent tiering is one option which you can rely upon if you are not sure where you want your objects to associate with. So you can select standard, and then you can move to intelligent tiering, by which S3 automatically moves across up, and this will be applied to individual object as well. So if you have a bucket and if you have two objects, object A and object B, imagine like your application is frequently accessing the object A, but same time it's only rarely accessing the object B, and S3 can automatically analyze if you select this intelligent tiering class, and based on how frequently that object is accessing, S3 will automatically move that to a different class, like the standard infrequent access or on-zone infrequent access, or even glacier or deep archive. So this is one of the good choice which you can make if you are not sure where you want your data to be stored. Second thing is like initially when we store something inside a bucket, naturally we may not have a clear picture of whether that particular object should be associated with a standard or infrequent access, or is it an archive type of thing. You can reduce that decision issues up to a level by selecting the intelligent tiering. But if you have an idea like, okay, I have an object, and after a period of time I can move that to infrequent access or something like that, then you can set the lifecycle policies in S3. So that can be applied from within the bucket properties. And if you apply the lifecycle policies, you can apply that lifecycle policies for a group of objects, for a folder, like we discussed earlier. We can mimic the concept of folder inside the S3 by adding prefixes, which is actually imitate the concept of a folder. You can have multiple folders inside one another, and this lifecycle policy for transition between the different storage classes, like we discussed earlier, the standard, infrequent, and the glacier, you can create these lifecycle policies, and this can be applied to a group of objects, or even for a folder or for buckets. So basically here you specify the transition rules, like you can specify the time frame after which, if that object is not accessible by your application, you can move that to a different class. Imagine I have an object inside a bucket, or a group of objects inside a bucket, and I can set a lifecycle policy, like if the objects inside this particular buckets or folder are not going to access by any of the application for a period of 90 days or 120 days, I can make a decision like, okay, let's move these to glacier class or deep archive class, and further after 6 months or something I can move that to deep archive as well, because then at that point I can make sure that, okay, this data is not going to access frequently, and definitely can move to deep archive or glacier or whatever class which we prefer. That way we can reduce the storage cost associated with storing those objects. So if you have a lot of data that you want to store inside S3, but at the same time if you want to reduce cost, you can move that to this archive type of classes. Keep in mind that there is a retrieval fee associated with when you store these inside in this type of rarely accessible object category classes. Amazon S3 expects you to store the objects inside that class for a minimum period of time, which you can check check inside, that's around 90 days or something. And if you are going to access the data before that time frame, you will be charged for the retrieval of data from those particular class. But the good thing is, like, if you are sure that okay, this data is not going to access for a period of time like 90 days or something, then let's keep that in archive, because the storage in that way can be reduced a lot. Similar way, you can also set expiration rules as well for deleting the objects inside a bucket. So everything that you are storing inside the S3 bucket has an associated storage cost or the retrieval cost. You can move that to a archival classes like a Glacier or Deep Archive. But still, if you feel that you are not going to use that objects at all, you can set the lifecycle policy for expiring that objects as well. That way, that objects can be completely deleted after a particular point of time. So I recommend you to check out the documentation and understand the difference between the different categories of classes that are provided for storing the objects. We understood, like, there is a frequently accessible object class which consists of standard and a reduced redundancy. The standard is the default one, and it provides highly durable, highly available with millisecond access to data. Then the reduced redundancies also fall under the frequently accessible object category. This is similar to standard class but with a less durability, because here in this reduced redundancy, your data is not replicated many times, and this is only designed for non-critical or reproducible data. And the cost is also a bit higher than that of standard. So this particular class, reduced redundancy, is not recommended at all. Instead, you can select the standard class. Then the other type of categories which we discussed already is the infrequently accessible objects, which consist of the standard infrequent access as well as the on-zone infrequent access. So standard infrequent access is a highly durable and highly available with millisecond latency. So there is a retention time that the Amazon expects from you for storing the objects inside the standard infrequent access class. There is a minimum retention time of 30 days, and the minimum billable object size is 128 KB as of the recording this session. But if you are going to retrieve the data before that 30-day retention time, there will be a retrieval fee associated with accessing the data. But the good thing is, like, if you store something inside this standard infrequent access, the storage cost will be much lower than that of standard. But there will be a retrieval fee if you are going to access the object within the 30-day retention or the minimum expected time which Amazon recommended for that. The 30-day retention time is what I understood as of recording this session. It can change at a later point of time. So I recommend you to check out the documentation to get access to and get understanding about the latest or up-to-date retention time that is associated with each classes. Similar way, there is an on-zone infrequent access as well. This is also very durable with millisecond latency. And here also there is an minimum object size of 128 KB and 30-day retention period is expected from you to store the data here. If you are going to access within that before the 30-day retention time period, then you will be charged for a retrieval fee. the on-zone, how it differs from the on-zone with the standard infrequent access is like here in this on-zone infrequent access, data is only stored in a single availability zone, and so it's a bit reduced available or less available than the standard infrequent access. However, because it is storing only in a single zone, that's the term it suggests, like on-zone infrequent access. Because it is stored, the object is stored only inside a single zone, the storage fee is much lower than that of standard infrequent access. And lastly, we understood about another kind of category of classes which is specifically tailored for storing the archive data. You may be wondering what all are archive data. So it can be, one example is the logs. You can store the logs associated with running your application, and logs may be useful for a certain period of time, like a 3-month period or 6-month duration, and after by which there is no point to keep that logs inside the standard because you may not going to access those logs frequently. So such kind of logs can be moved to an archive class, by which you can minimize or reduce the storage cost associated with storing that data. The one thing you can understand is, like, if you are storing the logs, that will be in a massive quantity, and definitely if you store that inside the standard class, you will be charged for a much higher, and the bill would increase a lot. So it would be definitely recommend to move that to a Glacier or archive class, and for that reason S3 provides the classes like the Glacier and the Deep Archive. So these are the Glacier. First we can look upon the Glacier. This is also a highly durable and very cheap storage class that is available from S3, which is specifically for the storing the archive type of data. And if you feel that you don't need that data for within a certain period of time, then you can store your object or move your objects using the lifecycle policy to this Glacier. Amazon expects a minimum storage time of around 90 days, and if you are going to access the data within that particular time, then you will be charged a retrieval amount for them. And another thing to understand here is, like, the data is not available in real time, and the data must be restored from the Glacier to the Deep Archive, and you will be charged for that. So there you should wait for a certain period of time to retrieve the data as well. Similarly, the Deep Archive is also a very highly durable, but it's very cheap compared to the standard class for storing the data. And if you want to restore the data from there, you must wait a few hours to get the data back, because that's the way by which those classes work. Like Amazon expects you to store the data there for a certain period of time, and if you are sure, okay, I can store the data there for that period of time without accessing it, then definitely go for the Deep Archive class. So this way different classes are there. Understanding extensively or even have a good overview about these different classes will be helpful to decide how you want to manage the data that is within the S3. If you are not aware of this, and if you simply store your objects inside S3, by default it will be under the category called the standard, and there will be a much higher storage cost associated with that, and the billing must you will be billed accordingly, and the bill must be very high. So to effectively store the data with the maximum cost effective strategy, you must have an understanding of all this. And as I mentioned earlier, even if you are not aware of all these things, Amazon provides a class called the intelligent tiering, which is a storage class that automatically moves data between frequent access tiers and this infrequent access tier. So that means that if you are having an object and if you put that if you have a bucket or something, and if you select that under the intelligent tiering, then if there is an object that have not been accessible for around 30 days, then automatically S3 will be moved that class to that object to object class from frequent access to infrequent access. So this way you can help to optimize the storage cost. There is no retrieval or revival fee is charged for moving the objects, but there is a small charge per object for movement into this tier. So that's one option which you can try out to optimize the cost. In addition to that, you can also have an aware about how best you can use the lifecycle policies, so that by setting the lifecycle policies, you can allow the objects to transition between the different storage classes. So you can set a lifecycle policy to move from standard to standard infrequent after a certain period of time, or you can move even just like the case of the logs, you can move that to a archive class like the glacier or deep archive. And you can also set expiration rules as well, which defines the objects to delete after a certain period of time. So if you feel that you can decide a lifecycle policy for a certain objects, then it's definitely recommend to go ahead with that. And Amazon has a documentation which is available in the S3 section, and if you check out that, you will get a comparison of all these different storage classes, based on which you can make a decision like which one to select. Now we understood a bit about the different storage classes, and we are now in a situation where we have a bucket and we have an associated set of objects inside the bucket. Next, we want to consume those particular objects from within our application. So when it comes to application, the one common need for your application is to query the data that is inside the S3. So to access the object that is inside the S3 bucket, you can either download that object and then can make a query. So that's the way by which usually used to do. But there is an associated feature called the S3 Select that is available from within the Amazon S3 Amazon services. So S3 Select is it works on a singular object level, and you can query an object, and using S3 you can query an object that is inside the S3, but you will be charged for that. So the some of the advantage you would get from using this S3 Select is like you can get a selective retrieval of data from within the object. So if you have an object that is stored inside like the CSV or some form of files like the JSON or something, you can have a selective retrieval of data. The way by which S3 Select, which is an extended feature of this S3, works with additional charge is like it uses a kind of a standard SQL like syntax. It's not SQL, it's actually a subset of standard SQL, and that way you can query the data from within the within the S3 buckets. So it also supports a lot of different file formats. It supports both the compressed and the non-compressed file formats, like the compressed gzip and tzip, as well as the non-compressed like the CSV, comma separated value, as well as the JSON. So if you are using an encryption that is inside your S3 bucket, especially the customer supplied encryption, we haven't touched upon the encryption yet. So encryption is the way by which your data is protected inside S3. Encryption, it's not particular for S3. Whatever data that you are going to store inside the cloud service, that must be encrypted, and by default all the cloud providers including Amazon encrypts your data by default. So if you store something inside the S3 like a file or JPEG file inside a bucket as an object, by default S3 will automatically or Amazon will automatically encrypt that data for your data protection, and it will store the data. Similar way, for other services like the relation database service or whatever different services that are going to consume the data or associated with storing the data inside a cloud service, automatically Amazon will encrypt that with it generates a key behind the scene automatically, and it encrypts the data with that key. In addition to that, there is a provision or feature which Amazon provides for you to provide a key so that it can encrypt the data with your supplied key. So that is called the server-side encryption with the key provided by the customer. In Amazon, you could see in the encryption section for S3, like what type of encryption would you need? Would you need an automatic encryption that is provided by Amazon, which is the default one, or a kind of an encryption with the key that is supplied by you, which is the SSC -C. That's the customer supplied key. So if you are using a customer supplied key, then during the usage of this S3 select, you have to provide the that particular key also for selecting the data with the help of S3, because otherwise you won't get the data decrypted in that way. So this is additionally priced, and this is charged based. The usage of S3 is actually additional priced, and it's not the encryption is actually priced like that. Sorry for the confusion. What I mean is like the S3 select feature, if you are going to use for querying the data inside the S3, you would be charged for that, charged based on the amount of data that you are going to scan and the amount of data that is returned. In majority of the cases, S3 select is not required. In that case, you can ignore this S3 select feature at all. You can simply query the S3. You can get a list of objects, you can download it, and you can then work on it. But imagine like if you have a list of CSV or JSON file inside the S3, and if you want to query the data that is inside that particular file, then without the help of S3, what you end up is like you need to download the data, download that different CSVs, and then make a query on the data inside the CSV from your application end, and then you have to provide the information to the user. So that would be time consuming. That's the way by which earlier application developers used to do. That is without this S3 select. So usually they download an object, then they will do a query from the application side. But with the S3 select, that's a feature that is additionally provided by Amazon, by which you need to pay a price for that, but the flexibility you as an application developer get is like you can use that S3 select inside from within the SDK, and then you can query from whatever objects that are inside the bucket. So at that time, when you initiate a S3 select request, Amazon will initiate the necessary queries on their infrastructure and they will retrieve the data, but you will be charged additionally for that purpose. But sometimes this is required, especially if you have a list of files that is inside a bucket and you want to query the files and make a return according to the query and to show the customer. Then rather than doing it locally at your application side, you can depend on the S3 select. Usually a majority of the cases what I saw is like the application developers tend to create a Lambda function. Lambda is a serverless function which you can create inside AWS, which is a separate service at all, and there is an additional charge for that. And inside that Lambda function, you can use this S3 select to query the data. Then I would like to mention one more feature or one more important thing you must understand as an application developer when working with S3. That's the concept of pre-signed URLs. This is not particular to Amazon S3. Almost all the cloud providers that have an object storage like the Azure Storage or Google Cloud Storage has this similar concept. So imagine a situation where as an application developer, you are going to store some objects inside the S3 bucket and you want to provide an URL or you want to provide some temporary access for someone outside your application. So it can be something like, for example, the one important use case which I have seen is like the user is requesting to generate a report, and majority of the cases we can generate a report on the fly and can show it to the customer. But imagine a situation where it involves a lot of processing to generate the report. We go for a queue-based pattern by which the user will initiate a request for getting the report, and then that request will be stored inside a queue, and there will be a background process associated with the request, and then it will process and generate the report. It will take some time to generate the report, and once the report is ready, that will be in a format like a PDF or Excel, and we need to provide that Excel to the user. Usually we notify them either through an SMS or through an email. So at that time, we will get an link by which we can download that report. So many instances we have seen this type of scenarios. If you want to generate a report like this and you want to provide a user with an URL that by which they want to access, then this pre-signed URL is very much required in those cases. So what you end up is like you will get a request from the user to generate a report in the queue, and some form of background process you can generate like a worker service or some form of Lambda function. You can work behind the scene and you can generate the report. And once the report is generated, you can store that inside a bucket, but that bucket will be accessible only for either you as an owner, or your application also can access that bucket. But what about the external users? We need to provide them a URL for accessing. At that time, programmatically using the SDK, you can generate a URL by which that URL will be publicly accessible for a limited period of time. You can set the expiration time. So that is why it is called the pre-signed URL with a time limit access on an object. So if you have an object, like if you generate a report and a report like a PDF, and you store that inside a report folder or report bucket inside Amazon S3, Using this pre-signed URL, you can grant a temporary permission on an object, and basically that pre-signed URL will be like a normal URL, and with the help of that URL, anyone in the public domain can access your object. So you must be very careful while generating the pre-signed URL. You should only provide that to the relevant users, and you must also set a time limit so that if some other person get access to that URL, and if they try at a later point of time, it should show a error like the URL expired or something. By that way that data would be protected. So whatever you are storing inside the S3 bucket, by default it would be private unless you explicitly provide a public access. Usually we don't provide a public access to a bucket because that's not safe. So if you want to provide a temporary permission on an object for an external person to download or something, usually we, as an application developer, you need to rely upon this pre-signed URL, which you can generate using the SDK that is provided by Amazon. You can, when you use that SDK, you can generate a pre-signed URL. You have to provide the bucket and the expiration time and the object information and all, and the SDK will give you that URL, and you can pass that URL to the your user using an email notification or whatever way which you prefer. Then using that URL, your users can access the objects. Otherwise that object would be private. So it involves a scenario like user getting an email with a pre-signed URL, and user clicks on that, and then an API call is triggered to the S3, and based on the your pre-signed URL, which can be valid for a certain amount of time. Like you can set the expiration time. Usually in the case of report generation, it would be maximum 30 minutes or 1 hour, and when we notify the user, we will specify them like this link will be valid for only 1 hour or so, by which the user can immediately download and get the report. Some of the things you must aware while generating the pre-signed URL is that it must be generated via the bucket owner. You must have a account within the Amazon, by which that account should own a bucket, and from within that account you should generate the bucket owner. So this pre-signed URL is on behalf of a bucket. So anyone who is receiving this pre-signed URL, they can access it. And this pre-signed URL to generate, you must use the AWS SDK. There is no way currently, as of the time of this recording, to generate a pre-signed URL through the AWS console. You must use the SDK and you must generate it. So far we have understood the different ways and extensive features of S3. Now you have a good impression that S3 is not just a simple storage, it's much more than that. In addition to this, sometimes for compliance requirements from an organization perspective, they need to track the request that is accessing this bucket. So different applications might be accessing your bucket. So you may need to make sure that who all is accessing that bucket. So we have a logging that we can enable inside the S3. That option is by default provided by S3, but that is not enabled. You have to enable the logging. So when you enable the logging, there won't be any charge associated with the logging feature which you are going to enable. But when you enable the log, S3 will be going to store the logs, and that for storing that particular logs, S3 needs a location. Usually you provide a different bucket for that purpose. So if you have a bucket like something like files or something, a bucket, just a fictional case, and if you want to store the logs associated with that files bucket, you can have a separate bucket called files-logs, which indicates that associated logs will be stored in that bucket. You can simply enable the bucket logging after that. You create the log for storing your first you create the bucket for storing your logs that are related to a particular bucket. So when you create that target bucket for storing the logs, make sure that you should provide a proper name by which you can understand what's the purpose of that bucket is for. So if you provide the main bucket name -logs, you can understand that okay, this particular bucket is used for storing the logs. You can have additional options as well, like while storing the logs, you can have a prefix for a particular bucket. In that way, you can categorize the logs accordingly and you can group the logs. That is a different way, but usually one approach is like you can provide a bucket with the same name as the first as the source bucket followed by the logs. That is one way. Another way is by which you can provide a bucket called the logs, create a bucket called simply logs, and then you can enable logging from different buckets with the prefix associated with each bucket. So when you enable the logging, you can set the prefix by which S3 will store the logs accordingly inside the folder. So it will be like if it is bucket A-logs or something, that way it will write. So now you may be wondering why we need a logging. So one important thing or the reason for enabling this kinds of logging for S3 is to track the request for access to a bucket. And this by enabling the logging, it records the information that is helpful for tracking. It tracks the time, the requester IP address, and what operation is actually the requested person is performing. So based on that, we can make a decision like, okay, is this a valid request or so. By default, this is not enabled. You have to enable it, and there's no charge for enabling the logging. But as I said earlier, there will be charge for storing the logs. And the generated logs are not in real time, so there may be a delay that you can expect for generating these logs. Logs are delivered from the S3 on a best effort basis, but sometimes it may delay depending upon the S3 service. So it's kind of it's not real time, but on a best effort basis, the logs will be generated. So enabling logging is definitely helpful, but you have to keep in mind that while enabling the log, you have to provide a target bucket. So you can enable this from the configuration section on the source bucket. You can also optionally specify a log prefix by which you can categorize the data. So by default, only the bucket owner has the full permission. So when you enable the logs, automatically S3 will add that user to a S3 log delivery group on the target bucket. So that permission is required. That write permission on the S3 log delivery group is required. So when you enable that, automatically that permission is applied to that particular user. And another very important thing to keep in mind is like both buckets, the source bucket and the logging bucket, must be owned by the same account. One of the reason by which we enable this kinds of logging is especially for the security and compliance reasons, especially the audit reason. Sometimes when the S3 bill goes very high, organizations are interested to know who is accessing that, and it's helpful if we keep a log. So, and that way from the log we can analyze the data. These logs are purely text files which are generated by the Amazon S3 service when you enable the logging. But by default, that logs from the logs it is very difficult to analyze who he is accessing a particular system, especially when a large number of requests are happening to a particular bucket. There may be hundreds or thousands of requests per second to a particular bucket. So from a just view of a log, it's not easy. You must use an associated log analysis services like the Elasticsearch or something like something from Amazon Web Service to analyze the logs, and based on that you can generate metrics or make decisions like, okay, from which IP maximum request is happening, and can make a decision. But other than that, from the logs itself, if you are not using any analysis service, it would be very difficult to track what is happening. So if you properly enable the logging and have a log analysis as well, you can have a very effective security and audit mechanisms in place, and this can help you to understand your AWS bill, and it can also help to understand the nature of request, which customer is using which bucket, and all those things. And the buckets which we provide for logging, keep in mind that logs will be built up over time. So you can rely on a lifecycle policy which we just discussed earlier to move the data, or either to delete the logs after a particular time or to archive the data to reduce the storage cost. So all the logs inside that bucket that is generated by the Amazon, it have rich information there, but unless you use an analysis engine, either you have to use your own analysis engine like the Hadoop or Elasticsearch, or from the Amazon there is a service called the Amazon Athena. By default, all the different logs, if you open each log and analyze what is happening inside there, it would be very difficult. So you definitely need an analytics engine mechanism, either your own Hadoop or Elasticsearch mechanism, or something from within the Amazon like the Athena, or whatever way which you like. So these are some of the important things which you must be aware of while working with S3. Using the logging, you can understand a bit of things, but sometimes you can also use additional services like the CloudTrail, which provides visibility into the different user activity or the API calls. So when you use the CloudTrail, some of the extra requests that are related to the S3 can be enabled from when you switch on the CloudTrail. So this when you enable this CloudTrail, it captures specific API request made to the S3 from your AWS account. So by default only the bucket level actions are captured, but you can enable an object level action by configuring an event selector. And just like I mentioned earlier, along with the having the concept of enabling a symbol logging, if you use the CloudTrail and also an associated analytics mechanism in place, that will provide a good auditing and compliance mechanism from within the CloudTrail. And when you enable the CloudTrail, it can capture the API calls that is routed to the S3 service, but have to keep in mind that not all the API calls are captured. Some of the API calls like the delete bucket or delete by lifecycle policies or get bucket information, get ACL put bucket information, of these all things can be captured. These are all different API requests. Basically the S3 is a kind of an API based mechanism by which the applications are accessing the S3 functions basically through an HTTP REST API. So each API call from your application will be captured. Even if you create a bucket from within the console, that is also an underlying API call that is happening behind the scene. So all the different API calls can be captured. Some of the main API calls can be captured by CloudTrail. So you have to check out the documentation from within the Amazon to understand what all API calls can be captured by CloudTrail. And if you get an associated proper log from the CloudTrail based on what you need, then that would be certainly helpful. And the CloudTrail log format would be in a kind of a JSON format, but the advantage is like you can integrate that CloudTrail with additional services like the CloudWatch, which can monitor and alert on specific metrics. And even you can create this CloudWatch log monitoring as well as the CloudWatch events, so that you can take a specific action and you can route that action to a Lambda or even other services within the Amazon, like the SQS simple queue service or the simple notification service or the stream analytics like the Kinesis or something. So there are different ways by which you can extend the logging from Amazon. We understood like we can enable a simple logging from S3, so that is the quite easiest method, but you need to use a analysis mechanism also in place to get something valuable information from those logs. In addition to that, you can enable the CloudTrail, which can capture the API request that is routed to the S3, and you can also integrate the CloudTrail with the CloudWatch. So CloudWatch is another service from Amazon. All these are different services. We started with S3. The logging along with the S3 is by default integrated with the S3, so that is included with the S3. But other than that, all the different extra things like the CloudTrail and this CloudWatch. So CloudWatch can be used to monitor the CloudTrail logs and can monitor and generate the alerts based on specific metrics. And if you want to further extend, you can associate the CloudTrail with a CloudWatch event, and then can be even further extend using the different other services like the SQS, SNS service or Lambda. So this way a chain of events can be triggered based on whatever is happening inside the S3. So it's like it's end up like S3 is much more than a simple storage of data, and that is the reason why when they started this service in 2006, so this is the initial service that is started by Amazon. It got a massive popularity at that time, and all the companies have requested additional services on top of the S3. So S3 is the foundation, and they have integrated different other services like the Lambda and everything on top of S3. So at that time they are in a situation like, okay, we are the companies or organizations are storing something inside S3, and once the objects is stored inside S3, okay, that is fine, but what's next? what we are going to do with the data. So at that time they used to pull the data from the S3 and to do further processing. But as things evolved, as the cloud evolved more, Amazon came up with more services like the Lambda and also this SQS and SNS and other services which have tight integration with the S3, so that the organizations can more effectively integrate the S3 object data with the different other services rather than creating a mechanism by their own. Initially, when they started the S3 service, when Amazon started the S3 service, organization used to pull the data from S3 and do the processing by their own. Now, with having much cheaper storage available and have a rich set of data inside S3, different other services can be integrated and can depend upon. Another area is like the analysis, big data analysis. So S3 can be used as a platform or the base foundation for storing the data, which can be used by other analysis services. So coming to the logging part, we gone a bit further, but again I want to come back to you to the logging part. Like when we store something inside the S3, we can have a simple logging as well as we can have an extended logging using the CloudTrail and CloudWatching, and we can even further extend that. So that's up to you on how you want all these things to happen. Now we will quickly cover upon some of the performance implications of S3 as well. So we understood that we can have at least a 100 bucket from within an account in S3, and each bucket can have multiple objects as well. We can extend the buckets, maximum buckets from 100 to further on a request to Amazon. But up to 100 it's fine because we can store additional objects that inside the S3 buckets, inside each bucket. So by default, when coming to the performance, Amazon created this S3 in such a way by which it is actually by default it is highly performing and highly scalable. That means that simultaneously at least around 3500 put or copy or post or delete request per second can be assigned to each different folders or different prefixes, and also around 5500 get or head request per second can be put upon each prefixes. So the thing is like if you have multiple prefixes on each bucket, you can simultaneously have around 3500. So that means up to you can have a get up to 5500 per each prefix inside a bucket. So that means if you have multiple prefix inside buckets, you can have a maximum of around 27,500 requests per second, provided if you have different prefixes. So if you feel that if your application is going to access massive get request from within an S3 bucket, consider splitting the data into different buckets, because each bucket can have a maximum of around 5500 get per request per second. So by splitting that objects inside multiple prefix or multiple folders in an easy to understand way, this prefix is we can construct a kind of a folder like structure using this prefix. So if you have multiple prefix and multiple objects inside each prefix, so your application can simultaneously request each prefix So each prefix will have each prefix can serve up to 5500 GET request. And similar way, if it's a put or post or delete or copy request, around 3500 requests per prefix can be made from each application. So that means that if you have multiple prefixes and if the application can make parallel request, then they can further extend that. So that way you have to decide how you want to create the system. So if you have if you want to have a highly performing application, you have to consider other factors as well, just like prefixing the objects, creating the different prefixes and storing the objects inside each prefix, and your application accessing those things. One another thing you need to consider is some of the limitations, like the network throughput as well as the memory throughput. So there should be a memory or network restriction for accessing parallelly. So that means if you want to perform a lot of GET request, you have to split across multiple split the request from parallel machines as well, because from one machine you can make up to a maximum of around 27,500, but you can use a combination of different parallel machines, and that way you can have a GET request of around 55,000 and more. So that means that one bucket will have multiple prefix, but you can't simply create a lot of prefix and have an on system accessing all those prefixes, because there will be a network limitation from each system from the network and the memory level. So first point is like you have to create different prefix and you have to store the objects inside each prefix as well, but also make it a point like how that data is going to consume or that data is going to process. So if you want to process that in a faster way, consider using different parallel instances by which each machine can parallelly access these different prefixes. So if you have in that way, one machine can maximum have a prefix of 4 prefixes simultaneously in parallel, and another machine can have another 5 prefixes. So totaling the request, if in the case of GET, it can be up to around 55,000 in that way. So these are some of the things you must understand, and main thing which I mentioned first, along with this, place your S3 bucket near to whatever services that are going to use the S3. So place it a region that is very closer to the end user. So you can also cache the frequently accessible contents inside an in-memory cache like an Elasticsearch, or if it's a video content, you can use the AWS Elemental Media Store to cache the content. You have to also you have to also aware that sometimes there is a possibility for HTTP 503 errors that can happen from S3 when lot of requests are going to happen. So you have to implement the retry mechanisms as well. So some of the SDKs are already having this retry mechanisms in place. Also, you have to parallelize the GET and PUT request for maximum performance. So if it's a PUT or delete request, or if it is a put or post request, then consider multi-part uploading for puts, and if it's for a GET, consider the range based GETs as well. And also for list, you can parallelize, and sometimes you can use secondary indexes or an S3 extra services like S3 inventory to query the S3 indirectly, rather than querying the S3 directly to reduce the bottlenecks associated with there. Then from the application point of view, application developer point of view, you can install the latest version of SDK, because some of these things like the parallel retraying and all are inbuilt into the SDK itself, and the exponential retry and all are built into the SDK itself. So you will get the advantage of using the SDK. And if you are using encryption, especially the customer side encryption, you need to provide an encryption key. Sometimes to manage the keys in a central location, organizations may use the key management service, which is available from Amazon. It's a central place to store all the secrets and keys. Just like there is a limit to the request that should happen to each services inside AWS, this KMS also have a limit associated with each key. So you have to be aware of that if you are using KWS along with the S3 for encryption key storing purpose. Because sometimes it may hit the KMS throttling prior to S3 throttling. So you have to be aware. So unless you absolutely require the KMS, make it a point to use the default encryption in place. If you are using KMS key limits, so while developing the application, you have to aware that key limits, and you have to mitigate the request accordingly, either using some other approaches like the inventory, the S3 inventory, or some other secondary indexes, or even sometimes you can store the data temporarily in a in-memory cache like the Redis cache or Elastic cache, or even the data inside a database instead of directly querying the S3 at all times. So once some object or files you can identify, you can store that details or store that information or path inside some secondary indexes like the S3 inventory or a secondary database, so that you can minimize the hit to the S3 in such cases. But the main point is like you have to analyze how much request that is going to happen from your from within your application to the S3. It should be the application that is consuming the S3 should be developed in such a way that it should not break because of this throttling. So that way you should manage to create the application. So I think we have covered enough of these things. I will quickly wrap up some of the important use cases that we use S3 for. Yesterday we have covered a few of the different use cases that we use S3 for. One is the application content storage or the object storage. That is one thing. Another thing is like S3 can also be used for as a data store for your data analysis requirement. Different services inside AWS can consume the S3 object and because of its tight integration with S3. S3 is a very popular service. So different services within the Amazon as well as even other services have good integrations with the S3 service. So that way you can store the data inside S3 and can have other integrations like the data analysis, or sometimes in the case of the backup services like the Cloudberry, that can store the backup to Amazon S3. Then you can also use S3 for static website hosting as well. That is another purpose. So if you have a React or some static website, you can store that inside S3, and you can simply serve the data because S3 is much cheaper. It's very cheap to host it and use it for a static web hosting. That is another thing. Then different other purpose, like for the organization to store the data or some content, you can have S3 for that purpose. Then if you want to store some content and to have some processing, then S3 is also a good choice because of its integration with other services like the AWS Lambda and also the different other services within the AWS, like the SNS service or the data analytics service or big data services or services like Amazon Athena and all, or different other services as well. So in that way, different use cases are there. I plan to cover another session on S3, different use cases of S3 later in this podcast. I will come up with that, and till then, have a great day and goodbye. So myself, whatever I present through this podcast are purely my personal opinion and do not represent any of the employer's view in any way. Thank you very much for listening this episode. I think this episode is now over 1 hour, and today is it's like 1.5 hours, a bit lengthy it became. Apologies for that, but I hope you got enough understanding of getting started with S3. There are much more details to know, especially if you are interested in knowing how the different organizations are actually using the S3. I recommend you to check out the Twitter handle called the S3 Storage, which is available from Amazon. So it presents that Twitter handle presents the different use cases of different organizations, by which you once you go through that, you can understand how effectively we can use S3 for serving our different purpose. So might be your use case may be similar to one which you can view in that Twitter handle. So you can check out that there. Then the other thing is like you can also check out the documentation, the different case studies, and can find out how the different organizations are using the S3. I hope this session and the earlier session will give a good background of getting started with S3. So thank you once again for listening this episode. Have a great day ahead.